In this Indiamoon video, we are going to cover Python modules. They allow you to do three major things. Number one, they can give you some extra functionality via the Python standard library, for example, random values or square root functions or anything like that. Besides that, they can also help you to organize your code via multiple files. We have our code spread over multiple Python files, and then we are importing things into one Python file that actually runs the code. Finally, what is arguably most important, modules allow us to import external modules, modules made by other people than the Python team. This is where Python really becomes powerful because you can import data analysis modules, game modules, basically anything you want. I'll cover that at the end. First of all, though, we can work with the Python standard library. This is just a set of inbuilt modules that give you lots of commonly used tools, like for example the math module for square root and then cosine and tangent. There's also a module for random numbers and a module for the alphabet, so if you ever need the strings of the alphabet, it's quite easy to get. You don't have to write it by hand. Back in importing modules, the code editor, I want to once again create a new file, and let's call this one modules. First of all, to get access to a module, we have to import it via the import statement, and this usually happens all the way at the top there. For example, we can find a module like math. This one gives you access to lots of MTH functionalities. Earlier in this series, we for example had the issue that we couldn't get the square root of a number. The way around that was that, for example, to get the square root of 4, we simply took the power of a half. That way we get 2 as a result, but doing this kind of operation is not ideal, and the math module can help you with that, because in there we have a square root function. To access that, we have to use the math module like a class, or rather like an instance of a class. We can simply type a dot, and then we get access to all of the math function. It contains the one we care about right now is sqrt, short for square root. In there we want to have one number, in my case a 4, and now if I run the code, we are getting the same result, meaning with that we have very easy access to a square root. On top of that, the math module has a huge amount of stuff that you could work with. For example, there's a tan, we have a ceiling, we have cosine, we have exponential functions, and basically anything you could work with in terms of math. Besides that, another useful module that I also have to import is called random. Random gives you, well, random numbers the way you would access, that is print random, and then once again you get a whole bunch of methods that you could be working with. Rand in is one of the more common ones. This one you have to call, and we have to specify two integers. Let's say we want to get a random number between 0 and 10. If I now run the code again, we getting 6. I run it again, 7. And we always get a random value between 0 and then we go all the way up to 10. So for rand in, the 10 is included, and well, that is all you have to understand for the basics of importing Python standard modules. All you really need is to do some research to find the modules that are useful for your specific purpose. For that sort of thing, you want to use Google. Once again, you want to look for Python standard library, and then you get to the Python documentation. You get a long list of Python modules that you could be working with. If you look in there, for example, we have the random module. That's the one we have just seen. If you click on that, you get a huge amount of information in terms of what you can do with it. It is quite an extensive module, so you do have to read this for a bit. Now, most of these modules you are never going to touch. For example, I have no idea what any trc file processing is. Same with pist files. I never used any of these modules. Most of the time you have one specific module that you are going to work with, and this gives you all you really need. Once again, this is the kind of thing that comes with practice. The more you work with Python, and the more research you do, the more you are going to come across modules that are really helpful for your specific purpose. Unfortunately, there's no quick or easy way to learn all of them instantaneously. I suppose what we could be doing, if I go back to Google, I want to look for Python module for alphabet or Python library and module are the same thing. If you are doing that, you are getting a couple of answers. For example, there we have W3 docs, and if you look at that, you can import string, and string has the attribute ASCII lowercase. This would give you the entire alphabet. In lowercase letters, the output is going to be all of this. This would be one example to figure out a module that could be useful for your purposes. Let's try this one. I want to import the string module, and after that I can print string, and then ASCII lowercase. Make sure to not call this one. It is an attribute, not a method. And now if I run all of this, we are getting the entirety of the alphabet, both in lowercase and then in uppercase letters. I should have specified here I want to have the ASCII lowercase. Now if I run this, we are only getting the lowercase letters, so all of this is still fairly simple. Now there's one thing that you can also do. Let's say in your particular code you only need ASCII lowercase, you don't need anything else from this module or library. If you want to do that, you can change the import setting to something like from string I want to import one specific thing, which is going to be ASCII, not letters but lowercase. If you are doing that, you have ASCII lowercase available like any other variable inside of your code, meaning I can get rid of the string dot, run the code again, and we once again get the same output. It isn't going to be a major difference, but this may be easier to read, at least on occasion. This would also work with methods. For example, if we only care about rand in, I wouldn't want to import all of random. I would from random import rand in, and with that I don't have a random available anymore. So if we are calling it like this, we would get an error. All we need is rand in with the usual arguments. So if I run this again, we are once again getting a random number, and with that we have covered the first part of modules. Next up, we can use modules to have larger Python projects that work over multiple files. Basically, all we are going to do is we are going to write Python logic over multiple files and then import things into one particular file and then run only that file. For that, back in the code, I want to create a completely new folder just to keep things organized. So new folder, and let's call this one multiple file project. Not the best name, but it's going to work for now. In there, I want to create two Python files. One is going to be main.py, and besides that, let's call it support.py. Both of these Python files should be inside of the same folder, and also let me close all of the other files. That way it's a bit easier to follow along. We have main.py and we have support.py. I want to get started inside of support.py. In there I can, for example, create a function. Let's call this one add underscore to underscore numbers, with number A and number B. The return value of all of this is simply going to be the sum of num A and num B. Also, we can create a whole class. Let's call this one test. Could also inherit, but it doesn't really matter. What I want to work on is that we have a variable, or rather an attribute, that can get a value of 1 to 3 and then a method so define. I suppose we can call this sum underscore method, that as always needs self as a parameter, and in there we simply want to print some method. With that we have a function and we have a class on top of that. I want to create a simple variable. The name could be var, and the value does not matter, just something is fine. All three of these things I want to use inside of main.py. And that I can do in a couple of ways. Most importantly, we will need the import statement, and then we have to import from the file name. In our case, this is going to be support because the Python file we import is called support.py and support gives us that after I have that I can use the content of this Python file like I would have it available inside of main.py. For example, what I could be doing is simply run test and then is assigned the instance of the class test I would need support and then test. Don't forget to call this one. And if I run the code now, we are not getting an error. Also, if you look on the left side, Python has created a package folder which you can ignore entirely, but it's kind of interesting that it does exist. It's there to store the connection between these two files. All that we want to do is to print test.a. and we can call test. Do I think I called it some method? And then we can run all of this and we get 1 to 3 and some method exactly what we have specified inside of the class. On top of that, we could also print the variable we have created. I call this one var, although you would have to make sure that you are calling this support.var. If I now run the code, we getting something the value we once again specified earlier. Finally, we can get access to the function via support.add_to_numbers and the numbers I want to add together are 2 and 3. The result we have to print. So let me wrap all of this with a print function and now we are getting 5. All of this is still working just fine. On top of that, what you can do if you only need one specific thing from a Python file, you can get rid of the import statement and replace it with from support import. And then whatever specific thing you need. For example, if I only care about test, then I would get the test class, and for that to work I would have to comment out the other two parts because those wouldn't work anymore simply because we haven't imported them. Also, it's not support or test anymore, it is simply going to be test. But if I run the code now, we are getting 1 to 3 and some method, the content of the test class, those two things on top of that. If you want to import multiple things, you can import test, then a comma separation, then var, and then add to numbers. Python is totally happy to mix the data types, so we have a class, a variable, and a function. Once we have that, I can uncomment things and get rid of support, and now you can use the variables and the functions literally like anything else inside of this document. And especially when you have more complex projects, this kind of setup is incredibly valuable because you can keep the main logic inside of one file and then all of the additional stuff inside of another file. You never really want to have Python files that get too long. It's simply becoming messy to work with. But once again, this is the kind of thing that you learn with practice. For now, I suppose don't worry too much about it. Although there's one more thing. At the moment, we are importing literally everything from the support.py file, which we can replace with an asterisk. That way you are importing all of the individual parts of this Python file, which is a bit easier to write. If I run the code now, we getting the exact same result, and the only difference from simply importing the entire support module is that you don't have to write support.py before the class or the variable or the function you have imported. Makes it a bit easier to work with, but that's about it. Which way is better is entirely subjective. Sometimes you do want to be clear about where a class is coming from, but other times you don't really care that much and you simply want to 3. Install Matplotlib, but other than that you are doing the exact same thing. In my case, I only want to type pip, and now if I press enter, Python is going to install this module, and this might take a second. Also, you have to be connected to the internet to make all of this work, and after a while you get everything is installed, and very often you get that a new release of pip is available which you can install with python.xdm pip inst upgrade pip. Although I am not going to do that, but keep your pip updated. It's generally good practice anyway. With that, we have one external module. If you want to have another kind of module, or you have some kind of specific purpose in mind, this is going to be a research project for you. It would take way too long to cover even most of the external Python modules. But anyway, let's create a basic graph. For that, we are back in the code editor, and I want to create a new Python file. Let's call this one graph. Then I can go into full screen, and first of all we have to import the module. Since we have in the PowerShell of the terminal installed Matplotlib, this is what we also want to import. So import Matplotlib. Now I want to run the code and nothing is going to happen. And that's a good thing. If you are getting an error at this point, something with the install went wrong, so double check that. But for Matplotlib, you don't actually import the entirety of the library because it is quite large. Instead, you import one specific part of it, which is going to be Matplotlib, and then pplot, which basically means we are importing the entire library, and from that we are taking one specific subpart. Also, what I forgot to mention is in the code writing, all of this would be kind of tedious because there are way too many characters. For that, Python has a keyword called s. We want to import this part under another name, and for pipl this is usually abbreviated as plt. That way it's much less typing after that. Since we want to create a basic graph, we are going to need some data. I want to have data for the axis, which can be just a list with the values from 1 to 10, and for that we can use list comprehension. So for I in range, I want to go from 0 all the way to 10. We want to go up to 11 but not included. After that we will need the y values, which could be another list comprehension. Let's say y for y in, and now I want to look at the x values, meaning y for y in x. That way we would copy this entire list, although for this one I want to get the power of 2 for every single value, and just to print what we getting, I want to print x and then print y. If I run the code now, we are getting the values from 0 to 10, and then another list with the same values, except every single one of them was taken to the power of 2. That would be some pretty good data. Now we have to create an actual plot, and for that we can use plt. All we have to do is get plt and then the plot method. This one wants to have 2 arguments at a minimum, in our case x and y. After that you have to run plt-show, and now if I run the code, Python is going to calculate for a bit, and there we are getting a graph. You could also save the graph and zoom in and move around, but I don't really care about any of those. All I wanted was a basic graph, which we have gotten via Matplotlib, and Matplotlib has a huge range of graphs that you could visualize. It's an incredibly powerful module. Also, what you could be doing before we are showing the graph, you could do, for example, plt and then x label. This one gives you a custom name for the x label. Let's call it the xais. Also, this has to be a string. The same thing we can do with plt. And the y label, let's call it something else. It really doesn't matter. If I now run all of this, we get labeled axes. You can see those down here and on the side. And that is pretty much all you need to import external modules. Now, unfortunately, every single library is different, so you will have to read some documentation to understand what you are doing in any given library. Can very often be a bit of a hassle, but you are getting a huge amount of functionality out of them, so it's very much worth the effort. But anyway, this is all I wanted to cover for this part, meaning we can do an exercise and then we are done. I want you guys to do some research, basically find some kind of external library that lets you print emojis. By the end, let's say you should be able to print the thumbs up emoji. Pause the video now and see how far you get. The way you want to get started with all of this is Python emoji module, and then you get to a website called PPI. On this website you can see all of the external Python modules. If you click on that, you get the line to install it, and you can also copy it to the clipboard, and then you get some examples on how to use it. For all of that, we have to start with the PowerShell or the terminal and then paste in what we have gotten from the website: pip install emoji on Windows and pip3 install emoji on Mac OS. If I now press enter, we are getting the entire thing installed, and that was all we needed. Now we can work inside of a code editor. Back in there, we first of all have to import emoji and try to run it. You should not be getting an error. In my case, that looks pretty good, so I am happy with that. Also, I am going to comment out all of the stuff for PLT because we are not going to need it anymore. Instead, I want to have an exercise, or rather emojis. The way you are using the emoji library is you have to print something, and then you want to print emoji do emo, which wants to have a certain kind of string. For example, on the website we could see red core hard, and don't forget to double colon on both sides. If I now run the code, we can see a red hard on top of that. What you can also do is simply add something else before that. You can write Python is and then run all of this again. Emoji is only going to look at what is inside a double colons, in our case the red hard, so it's going to ignore Python is also if it doesn't know the command. For example, if we only add hard, I think this one doesn't exist, then we simply get Python is hard, so this one doesn't do very much. And well, all we have to figure out now is how to get thumbs up, and this we get via typing thumbs up. Now I can run this and we get a thumbs up symbol. There are quite a few names that you could be using here. For example, if I copy one in, we have winking face with tongue. If I run this, we are getting that particular emoji. And once again, if you are doing some research, you can find all of the options. Emoji actually has quite a bit of functionality, but in our case this isn't too important, and this is very much not something you should be overusing. But anyway, with that we have covered all of the basics of Python, so I hope this series was helpful.